All right, this is number 10, activity 2.3.1. So we've got a solid circular titanium rod to hold up a force of 7,000 pounds. Elasticity of that titanium that it's made out of is 60,500. Deformation should be 0.2 inches when the stress is 42,000. Determine diameter and rod length. So we know stress, 42,000 psi. We know deformation, 0.2 inches. We know elasticity, 16,500,000 psi. We know force, 7,000 pounds. Anything I'm missing? I think that's it. What do we not know? We need to know area so that we can find diameter. And we need to know the length of the rod. So I'm going to start with the length of the rod just because I feel like it. And the only formula I know with length in it is the one that says strain is equal to deformation over length. Strain, not given to me, but I know that modulus of elasticity is stress over strain. And I know both stress and modulus of elasticity, so I can change that to say strain is equal to stress divided by modulus of elasticity. So let's start there. Stress is elasticity. The stress we said was 42,000 psi, and the modulus of elasticity we said was 16,500,000 psi. Cancel 3 zeros. 1, 2, 3. So it's easier to put in my calculator. Right? 42 divided by 16500. And we get that the strain is 0.002545, and that just keeps repeating. Now that we know strain, we can use that to figure out length. So if I rewrote the equation for length, multiply by length, divide by strain, it is the deformation divided by the strain. And deformation, we said 0.2 inches divided by the strain, 0.002545 repeating. So 0.2 divided by the answer. And that gives me a length of 78.57142.857 inches. All right, so that is the maximum rod length that we can have. Let's take a look at the diameter, which means area, and the formula that we typically use with everything else that we have is we say, let's go over here, modulus elasticity is the force times the length divided by the deformation times the area. But we want to solve for area, so area is the force times the length divided by the area times the deformation, times the modulus of elasticity times deformation. So force, So force is 42,000, no, force is 7,000, pounds. Times the length, we just said 78.57142.857 inches divided by the 16,500,000 psi times the deformation, 0.2 inches. And just plug it in, 7,000 times our answer divided by parentheses 16,500,000 times 0.2, and that gives us an area of 0.16 repeating inches squared. And what do we do with area? We use our diameter formula, so area equals diameter squared divided by 4 pi. So diameter would be equal to the area times 4 divided by pi, and take the square root of it. So diameter equals 0.16 repeating times 4 divided by pi square root. So times 4 divided by 3.14, and take the square root of that. So it tells me the diameter would have to be 0.4607756776 inches. There you go. And that's how we do it. That's the last one. Hope you guys get them done by Sunday, and I will answer any questions that you have. Send me an email or Zoom with me on Friday. Have a good one.